Hi, it's Hugh here for Tone Twins TV and another solitary episode, I'm afraid. We're back in lockdown here in Wales. So no Ed, but we do have one of Ed's recently acquired amplifiers, which is this rather lovely late 1950s Tweed Deluxe. At least it used to be Tweed. Somebody's obviously pulled off the Tweed covering at some point in the past and revarnished it with this kind of brown varnish. We think it looks cool, and a lot of people suggest that these amps actually sound better without the covering, so we'll certainly be finding out if there's any truth in that. The idea behind this DIY video is basically to go through the amplifier, firstly make sure that it's safe and it's been grounded properly and there's nothing dangerous in there. The other thing we want to do is establish whether it's been modded over the years, and if so, revert it back to proper 1950s specs. There's going to be routine stuff, making sure that there are no leaky capacitors and making sure that the amp is biased properly, and hopefully get this thing sounding as good as it possibly can. Let's take a closer look. Stripping off the Tweed has revealed which parts of the cabinet are made from pine and which are made from plywood. The control panel is dirty, but the silk screening is still in great shape and all the original knobs are still there. All this paint residue on the edges of the original grille cloth suggests that this amp has been various colours over the years. Jensen P12Qs are my absolute favourite vintage Jensen Alnico speakers, and the date code on this one corresponds to the 49th week of 1958. The stamped date codes on these Schumacher transformers correspond to the 46th week of 1960, and the label date, which is KD, is April 1961, so these transformers are almost certainly original to the amplifier. Before starting a project like this, it's great to know that the amp's actually working. If it's not working, it's a completely different type of project. Ed assures me that this amp actually works, but I wouldn't even be plugging it in if I hadn't actually established that it already has a grounded mains cable. I think we can safely say that the amp is working, and it's now time to have a look inside. But before we do, I just want to make a couple of points about safety. Firstly, this is not a video designed to teach you how to work safely on valve guitar amps. There's plenty of videos like that, and I suggest you check them out on YouTube. I found Uncle Doug a really great resource, D-Lab Electronics. Anyway, just a few safety tips. Firstly, amps like this can kill you, and you really do need to take great care. You do this at your own risk. There's only a couple of times when it's actually necessary to have the amplifier plugged in and switched on, and that's when you're checking voltages and you're checking bias. At all other times, the amplifier should be unplugged from the mains, and you should drain the capacitors off using a drain resistor. I'll show you how to do that later in the video. Always work with one hand behind your back if you can, especially when the amp is live. Stick it in your back pocket. You can put a rubber glove on it. You can do both. Just the worst thing you can do is to grasp the chassis with one hand and then touch something live with your working hand. The shot can go across your heart, and that can kill you. Probably will kill you. Another good safety precaution is to wear thick rubber-soled shoes. You can wear work boots, you can wear Crocs, you can wear wellies, you can even wear a pair of creepers. It doesn't really matter, so long as there's a thick rubber layer between your feet and the floor. With all that in mind, let's crack on and see what we can do with this amp. The amp is in pretty good shape electronically and has obviously been worked on. It certainly had all its electrolytic caps replaced. Many 1961 Deluxes have those great sounding blue capacitors that you often see in brown face and black face Fender amps. They rarely go leaky, and it's unfortunate because only one of these Astrons is even of the correct value, which is 0.1 microfarads. It's likely that none of these are original to the amp. All of these potentiometers look correct apart from possibly the tone pot. It's certainly old and it could be original, and I have measured it and it's the correct 1M value. The filter caps have all been replaced and the value has been changed from the stock 16 microfarads to 22 microfarads. This change, along with the lowering of the signal cap values, may have been an attempt to tighten the bass response. The spider who wove this web clearly wasn't up to speed on health and safety, much like the person who installed this new mains cable. The wiring has not been done correctly, and there's no cable retaining clip in the chassis. The ground wire is held on by solder alone, and there's no mechanical connection to the solder tag itself. The tube complement includes a GE rectifier and two RCA 6V6s, along with an RCA 12AX7 and a Mullard ECC81. ECC81 is just a European way of saying 12AT7. The input wiring is a bit of a mess. There are two replaced jack sockets and a whole load of new cable. I'm going to have to tidy this up. Okay, first things first. This little thing here is a drain resistor. It's 22K on a couple of alligator clips. What I'm going to do is I'm going to attach one end to a transformer screw which connects to the chassis, and I'm going to connect the other end to the positive of one of the power supply filter capacitors. Okay, there it is, probably a little bit out of focus, but that's going to drain off any residual charge in the amplifier. Just leave it a couple of minutes. And out it comes. Next thing to do, just gonna put my multimeter onto this. The negative side is connected to the chassis, and I'm just gonna measure for voltage, just to confirm that the amplifier is completely drained. And there's no charge left in the amplifier. It's now safe to work on. And the most important thing of all, unplug from the mains. We're going to attend to the mains wire first, and there are two main things we need to do. The first is to put a cable retainer into the chassis to prevent the wire being pulled out by accident. The other thing is to get this wired up properly. You notice there are three wires. The green one is grounded to the chassis, which is correct. Then we have the live wire, which is the black one, and we have the neutral, which is white. The live wire from the mains cable, the new mains cable, is going to the fuse, and then from the output of the fuse into the transformer. And the neutral is going to the switch, and then the output of the switch is going to the transformer. This is not really the way it should be done. The neutral should go straight to the transformer, and the live should go to the fuse, which it is, and then from the fuse to the main switch, power switch, and then from the power switch to the transformer. Okay, so the fuse and the switch will both be on the live line. So I'm going to change these wires around now, secure the cable, and only then will I start doing any work on the rest of the amplifier. Okay, and the mains wiring is complete. The most important connection is this ground one here, which is going down to a solder tag which is connected to the chassis. The neutral is connected to the black cable that goes directly into the transformer, and there's heat shrink on that to keep everything nicely insulated. The live is now going to the fuse holder, jumper wire from the fuse holder to the switch. Unfortunately, I didn't have any black wire, believe it or not, and then from the switch into the transformer. So this is all wired correctly now. The cable is secured with a cable clip here, and we can carry on with the proper restoration of this amplifier. Okay, these filter caps are going to come out next, and the way they installed these was they simply snipped out the old ones and then wrapped the lead out wires from the new capacitors around the protruding wires coming off the circuit board. So I'm going to get this all cleaned up, basically remove all the solder from the eyelets, connect the new capacitors properly, and I am going to renew all the solder joints. I'm also going to take a look to ensure that this resistor here, which is the drop-in resistor, is the correct value, and just tidy up the wiring. And I'll be replacing this little 22k drop-in resistor here, which has probably seen better days. It's probably had a hard life, so just put a slightly higher value, 22k in there. Well, all three filter caps are out, and I've cleaned out the solder from all 6 of these eyelets as best I can. There's always some wires sticking through, which are often just ground jumper wires or other connections in the circuit, so be careful you don't lose them. This is quite interesting. I've pulled this out. This is the dropping resistor, and it's an old true ohm, but it's actually 350 ohms rather than the 5000 or 5k that's supposed to be in there. I pulled out this 22k as I said I would. Might measure fine, but I think it's just time to put it into retirement really. And these are the 22k filter caps that I've pulled out. These are probably fine, but Ed wants to hear how the amp sounds with the original 16Ks, and I tend to agree with him. But if we prefer the sound with these, if it's a little bit tighter, we can always just pop these back in a matter of minutes. So I just tested these new filter caps and the drop-in resistors. Everything is working really well, and I'm draining off any residual voltage in the amplifier with my drain resistor, as we discussed earlier. Next job is to remove all of these Astron capacitors. They look like they're original to the amplifier, but only one is of the correct value, and Ed wants to hear what this sounds like with the correct value capacitors. I'm going to be putting in a set of Mallory 150s. I tried the yellow Jupiters. I don't particularly care for the sound of them, and they're more expensive than the Mallorys, which I do prefer. So these are coming out. I'm going to test these, because if they test good, I'll mark the good ones, and Ed will be able to use these in another vintage Tweed amp where these values would actually be appropriate. As you can see, we've got all the signal caps out. This resistor here is a replacement, which is a 56k. It's one of the plate resistors. These look like they've been replaced as well. These are 100k resistors, plate resistors for the first valve. I'm going to take these out and redo it. This is not the way Fender would have done it. It looks a little bit scruffy, and I think changing plate resistors is a sensible idea in order to maintain a lower noise floor anyway. So I'm just going to show you what I do to clean out the eyelets. So I'm just going to heat the solder in the eyelets. Solder sucker goes on. Usually takes a few tries to do this. Okay, if you look at this one here now, you can see that the components are still mounted in there. There's a nice big gap for me to get the lead out wire from the new capacitor installed. So I'm going to do that with all of these eyelets that have previously been soldered. In fact, I'll probably renew all the solder joints just to reflow them and try and avoid getting any dry joints, which can cause problems in amplifiers like this. As you can see, I've removed all the signal caps, and I've also removed all the plate resistors. There were 4 of them for the 2 preamp valves. They're a major source of noise, popping, hissing, all kinds of nonsense, and they're routinely replaced. A lot of people put modern style carbon film or even metal film resistors in here. I'm going to put carbon comps in. If they're noisy, then I'll change them for something else. But if there's no noise issues, I'll put carbon comps in because it looks right, hopefully it sounds right, and if there's a problem, they're such cheap components, it costs next to nothing. I've also hoovered out the inside of this chassis because it's over the years they get full of dust and metal dust and filings and bits of old component legs and all kinds of stuff. So I've cleaned it all off, and I've also cleaned the board as well to get a lot of the excess resin that's boiled out of the eyelets. So I'm going to load everything back in now, and hopefully that'll be the major part of this restoration done. I've installed the plate resistors. We've got a 56k here, and then we've got three 100ks. I've done them in the proper Fender style where they join at the eyelet, and I've soldered the joins here, but I've left these four eyelets unsoldered because they're going to be needed for the signal caps that I'm going to put in, and it's easier just to leave these open so I can get the leads in without any difficulties. All of the signal caps are in. These are Mallory 150s, and you may notice that I've put a black band at the end of each capacitor. That's because I tested to see which end was the outside foil, and if you orientate them properly, it keeps the noise level in the amplifier as low as possible. So the next thing to do now is tidy up this input wiring, and I'm going to do a little bit of a modification to keep the noise level down as low as possible. I've stripped off the input jacks, and I'm going to reassemble them on the outside of the chassis. To get around this leaking current problem with the circuit board, I've installed a set of jumper cables that go directly from the input jacks to the grids of the first valve via 68k resistors. I'm pleased to report that the amp is working really well now after all these components have been replaced. It's a little bit quieter on the inputs thanks to the modified input wiring, so not getting that scratchy pot thing, and it's time to check that the output tubes are biased properly. There are various methods for doing this. If you use the cathode bias resistor method, you just get an average reading for these two, but I prefer the method that Uncle Doug demonstrates from D-Lab Electronics. It's a really in-depth video on tube amp biasing, and I suggest you watch that because it's probably the best one I've seen. But in brief, what I do is I measure between this point here on the rectifier tube, which is the center tap of the output transformer, between that and each of these plate connections on the 6v6s. Do that with the amp unplugged and fully drained. That gives me a resistance reading, or two resistance readings rather, and what I then do with the amp switched on, observing all the safety protocols, I measure the voltage drop between the center tap and each of the plate connections of the output tubes. So if I divide the voltage drop by the transformer resistance, using Ohm's law, I can determine what the current draw is for each of these 6v6s individually. And in this case, I ended up with 35 milliamps on this one and 44 milliamps on this one. And I also measure the voltage on these plates, multiply that by each of the current readings, and I can get the plate dissipation. And in this case, it's 11.6 watts on this one and just over 14 watts on this one. So this one's running just a fraction hot, but it's probably okay. This one's running cool, and not a great balance between them. So my feeling is Ed's going to be better off with a better balanced set of 6v6s, and then we'll just recheck the bias after we've installed those. And the job is done. I've installed a couple of Mullard branded 6v6 power valves from a Bell & Howell projector amplifier that Ed also owns, and they've balanced up really nicely. With the original 250 ohm bias resistor, I was getting 12.5 watts on this valve, and I was getting 13.25 on this one. I've changed the bias resistor now to 220 ohms, which is generally the value I settle on with these old Tweeds. And I'm now getting 13 watts on this valve and I'm getting 13.7 on this one. I think that's a really good balance, and they're just shy of maximum plate dissipation, which is 14 watts. So I'm happy with that. I'm going to call this job done, and time to test this out and hear what it sounds like. Hope you enjoyed the sound of our restored 5E3, and you may still be wondering why we put so much work into restoring an amplifier that was already working just fine. Well, just to recap, the mains wiring was a bit of a mess and it wasn't secured properly to the chassis. It had been grounded, but it hadn't been wired to modern safety standards, so all that has now been rectified. Similarly, the input wiring was pretty messy and we were getting a noise problem with scratchy pots with all our guitars as a result of current leaking across the circuit board. But the main reason for doing this is that Ed has started a new business called Vintage Tone Factory, and essentially what he's doing is offering a reamping service. So if you record your guitar sounds direct onto your hard drive, direct inject, DI, you can send those sound files to Ed. He'll spin them through any amp in his rather extensive classic amp collection, anyone you choose, and give you a choice of speakers, give you a choice of microphone, preamp. He'll re-record those sounds and then send them back to you so you can spin them back into your tracks. The amps he wants to offer are going to be as close to original specs as possible, so that's why we decided a bone stock 5E3 rather than some randomly modded 5E3 would be more appealing. Anyway, hope you enjoyed the video. Keep checking in because there's more to come. Don't forget to subscribe, and we'll see you all again soon. Dabo.